Thanks. Hello, everyone. So, first of all, before I get started, I'd like to ask a quick question of the audience, just to do a quick straw poll. So, could you put your hands up if you use Adobe Reader? Oh, a few people. Okay, keep your hand up if you use Adobe Reader, right, and put it down if you understand the attack surface. Okay, so it's kind of mixed. It's kind of what I expected, and there's probably a lot less in this room here of people who use Adobe Reader, perhaps because we're in the security industry. So that's kind of what I expected from that, and the fact that there's few people here who perhaps don't understand the software, understand the attack surface of the software. So that's interesting, and hopefully you'll learn something from this talk, which is something we'll cover. So, I'm David Middlehurst, and I'm joined with my colleague James Loureiro from MWR, and we're both security consultants. My background is conducting security assurance projects and simulated attacks on a day-to-day basis. My specialisms are application security, tool development, and vulnerability research. James has more of a background in vulnerability research, reverse engineering, industrial control systems, and embedded systems. First of all, how did this presentation come about? Well, earlier in the year, BSides launched its call for papers, and there was 3 topics that they suggested for the call for papers. There was operational security, attribution, and making a difference. And the final one, making a difference, was where we thought we'd try and do a presentation. So at the time, earlier in the year, we were looking at the Pwn to Own competition at MWR. So myself, James, and a few others at MWR were looking at Pwn to Own. And one of the targets for Pwn to Own was Adobe Reader. And so we began looking at this, and Adobe Reader is a good example of a piece of software which has had its fair share of scrutiny over the years from our industry. And we thought that we'd share our approach and the methodology we took in assessing this piece of software. So a quick overview of the agenda for today. So first of all, we're going to start with software security in general today, what you might expect from a piece of popular software. From a security perspective, what perhaps is happening behind the scenes before the software even makes it to release. Then we're going to take Adobe Reader as a case study. We're going to explore its attack surface. We're going to have a look at the areas such as the JavaScript API, how you might fuzz to try and find vulnerabilities in the PDF file format. We'll then move on to some mitigations such as the sandbox, and then we'll draw some conclusions. So how are vendors improving security? Generally, vendors of popular software have improved their security posture of the software, and they're a lot more switched on with security generally. If you've got a piece of popular software, you'd expect some of these things to be happening behind the scenes. So you'd have an in-house security team carrying out some of these other activities. So they might do their own security research, they might get independent testing, they might do code review, implement a strong secure development lifecycle. They might look at implementing exploit mitigation techniques, and perhaps do their own fuzzing. So as with the Chromium project, the Chromium project and Google do a lot of fuzzing and find a lot of bugs before other third parties do. So they do a lot of fuzzing themselves, and this is to be expected for some popular software nowadays. So why bother assessing popular software? You know, you've perhaps got Project Zero, you've got some big names looking at, pieces of software like Adobe Reader. Are you going to find bugs? Well, we like to think so, and this is when we started this project, we thought, well, we didn't have a great time frame for the Pwn to Own competition from when the target list got released. So we started looking at it, and we thought, well, we'll give it a stab and see where we get with it. And we really wanted to share to the community our general approach of how we approached Adobe Reader, and hopefully share some of the things we found. So moving on to the case study of Adobe Reader then. So Adobe Reader is implicitly trusted by enterprise and home users. So I had a look online at some resources to try and establish the market share that Adobe Reader has. And there was a recent Secunio article which suggested that it could be greater than 80% market share that Adobe Reader has of the PDF reader market. So it's not hardly surprising that we had a few hands in the air that you use it. Whether that's your choice or it's your employer who forces you to use it, I don't know. But I don't know. But PDFs in themselves are generally trusted. They're built around the internet. We all use them every day. People generally aren't too afraid of clicking on a PDF. But despite Adobe doing some of this good security stuff, so probably some of the stuff from what we were talking about in a few slides ago, there's still bugs found, and there's no real sign of decline. This is the graph of CVEs for the past, since 1999 to 2015. So far this year, there's a decent number, and for the past number of years, it's been quite sporadic. There's no real sign of slowing down, and we'll maybe come onto this a little bit more with the attack surface of why this might be, because the attack surface is perhaps quite vast. So in terms of high-risk CVEs with a score of CVSS 7 or more, there's actually 31 been reported to date this year, 37 in 2014, and 65 that was a good year, in 2013. So before we start looking at Adobe and going for bug hunting with this product, let's look at the latest Adobe Security Bulletin, which was released in May. This is how they classified the vulnerabilities which they fixed in that release. As you can see, 14 JavaScript API security bypasses. There was 10 unclassified memory corruption bugs, five use after freeze, a couple of buffer overflows, and an XXE vulnerability. So these are the types of areas where we might expect to find vulnerabilities in this product when we start looking at it. So before we got started with this product, we'd obviously looked at this, CVEs, we'd looked at some of the output from Project Zero on this target and other useful things. But these are the key resources that we really referred to before we got started approaching the target. So we obviously went to Adobe for their standards and documentation, and some of their engineering team's output is extremely useful, especially if you're, for some of their sample files and exercising some of the functionality. Cork and me, he does a good course called PDF 101, which describes some of the intricacies of the PDF file format and some of the tips and tricks that you can use to create PDFs. Didier Stevens has done some good research over the years, and we'll perhaps touch on some of his research in embedding an XE. So he found that embedding an XE in a PDF, and that was bad. You could dress up the dialogue which comes up to launch the XE, so that's generally a bad thing. And then 3 presentations in particular helped us out a great deal with different aspects of the attack surface. So the life of a JavaScript bug, that's a brilliant presentation. It takes you right through from for a privilege escalation right through to some of the things you could do with that, and we use that when we looked at the JavaScript API. For the sandbox, these 2 presentations, one at Black Hat Europe and one at CanSec West, were incredibly useful. Finally, I mentioned government hardening guidelines because these are quite useful. So the notable ones for Adobe were NSA and DSD. Essentially, this is the information that Adobe puts out to give advice to their government departments, how they think that the product should be locked down, and hence where they perceive the attack surface to be. So this is useful, knowing what they tell you to switch off, essentially. So what did we perceive the attack surface to be? So we mentioned, so there's the JavaScript API, which we'll come on to in more detail later. Parsing and rendering of PDF files themselves, so file format type bugs. Extensions, so there's a lot of inbuilt extensions with Adobe Reader, and they also open up an SDK to allow you to develop extensions for the product. But one of the extensions which comes as standard is XML forms, so that's something you could approach. I mentioned embedded files, and that's something that Didier Stevens did with embedding an XE. Can you embed other dangerous content within PDFs? That might be an option. And there's some security features such as document signing and the concept of a trusted publisher. And perhaps if you trust a publisher, then it maybe gives you more permissions within Adobe Reader when you open a PDF file coming from a trusted publisher. So essentially with the attack surface, we shared this out among the team, and we all kind of worked together, but one of the things which I looked at was the JavaScript API. So as it says here, this is from Adobe's site. JavaScript and Adobe Reader, is it a good idea? I don't know. But it essentially means that you can generate PDFs which are interactive. They perhaps have a form and they connect to a database to store the results. This allows developers to do weird and wonderful things with PDFs. And so it's based on JavaScript version 1.5, ECMA script. And this is very much similar to the JavaScript you might find in a web browser. And could be invoked from a HTML page. So before we looked at the JavaScript API, some useful documentation was the JavaScript API documentation, and we'll come on to this a little bit later, but you can also decompile the SpiderMonkey bytecode, and in the presentation I mentioned the life of a JavaScript bug. It gives you a bit of that background on how you might do this. To play with JavaScript in PDFs, you've really got two options. You can either make PDFs with JavaScript embedded, or you can invoke the JavaScript console within Adobe Reader, and you can interact with this directly. I wanted to first of all share some just very simple tricks on how you can play with JavaScript in PDFs. So on the left here is a PDF, and that's a valid PDF. We've got a stream here, which is a JavaScript stream, and I'm just spawning an alert dialog, a hello dialog here. Within Reader, when you open this PDF, you get the hello dialog popping up. Obviously, replace this with whatever payload you'd like to play around with, and then that's the option. So one way you can do, one simple Python script you can use to create these PDFs is a script from Didier Stevens' PDFs toolset. And if make PDF JavaScript, you simply specify the JavaScript file you want to embed in a PDF, and it'll load this JavaScript when you launch the PDF. So I mentioned the JavaScript console. So to actually get access to the JavaScript console, if you incorporate this in, so the way I did it was that if you create a PDF with simply console.show in it, then it invokes the console. There are a few other ways you can save a shortcut within Adobe Reader itself, but this is a simple trick. It will invoke this dialog here, which is the JavaScript debugger. With this JavaScript debugger, you can type JavaScript into the console and press Control-Enter, and it will execute the JavaScript. And this opens up the JavaScript API to you. Some other tips and tricks which are worth mentioning. You can call a function with the parameter acro-help, and it will return some output which looks like this. This is useful for fuzzing because it gives you the expected expected parameters that the function expects along with its data type. And those in square brackets indicate optional parameters. As with all JavaScript, you can iterate through what's there and to enumerate the objects and functions which are present within Adobe Reader in a quite an active manner. I just use this little snippet to produce a list like this, and I'll come on to this a little bit later as well. But this is iterating the app object within Adobe Reader, which we know is present, and things like alerts stem from this. And this is all the nested, some of these are objects, some of these are functions, and we'll come on to a tip now. So this is one way you can establish that. So if you call, say, app alert, and then call to string on it, as you can see, you'll get a response here, which indicates that this is implemented in native code. This is important for fuzzing because this is probably more attractive fuzzing target because it's implemented in native code than other functions like this, which are implemented in JavaScript. I'm just calling to string on this function the same way as that one, but that indicates that it's implemented in JavaScript rather than native code, and hence some of these calls that makes will be implemented in native code. So it's still valuable for fuzzing, but there's probably other checks which are going on in this function which won't, so you're probably better off focusing on these for fuzzing if you want to fuzz this. So to work with this, I developed a proof of concept tool, and I'm going to show you a demo in a minute of this tool. So essentially, it is just a proof of concept. It's not ready, and we will release it once it's a little bit less rough, and hopefully the demo will work today. So we've got, it essentially interacts with the JavaScript console, but instead of typing manually into the JavaScript console, it interacts with the JavaScript console via the Win32 API. It essentially just grabs a handle to the JavaScript console and sets the text and then executes with Control-Enter like I described in the last slide. So I'll just move on to the demo of this tool now. So hopefully show you something working. So first of all, I've launched the tool here. And what I'm going to do is I'm going to click the console button. As you can see, it's invoked a PDF with the JavaScript debugger active. All this is doing behind the scenes is really dropping that's the PDF I told you to craft with console.show in it. Once this is running, my tool, if you click enumerate, it'll start typing into the JavaScript console, start iterating using introspection to get the nested objects and functions within Adobe Reader. The reason I did this was I wanted to have a tool which interrogates what's there, does some enumeration, does some information, it gathers as much information about the functions which are present and the ones which I might want to target for fuzzing, and then goes off and fuzzing so I can scale this tool up eventually. So what I want to do is, it's a populated tree view here on the left-hand side. If I start to expand that out, as you can see, within app, here's all the nested. Some of them are objects, so media is an object. Some of them are functions. If I then double-click one of those, it's identified it's a function. It's identified it's in native code. It's identified that it expects a string parameter. If I then flip back to the tool, as you can see, it's extracted this information. It's parsed out some of the parameters. It's found that there's a mandatory parameter of a string, which is the policy file. And then you've got something which you can work with to fuzz this. I've half implemented a fuzzer, and as you can see at the top, there's a fuzzer which isn't quite there yet, and we've not necessarily found some bugs with this alone, although the enumeration has been useful with this tool. But I also implemented a regex fuzzer, which fuzzes the regex engine by basically constructing a simple test case which says, oh, here's a string, let's try and match this regex against the string. I just wanted to show you what happens when it's an object rather than, so it's identified that's an object. If I click on that, it's found nested objects and functions which are present below app media. And essentially, when in the earlier revisions of this tool, I just left it running overnight, just finding stuff. There are some loops in there, so be careful though. So a final point on the JavaScript API. We'll touch upon some of the security considerations with the JavaScript API a little bit later in the presentation. But I mentioned you can decompile the SpiderMonkey bytecode. If you follow the steps in the tool, which was released in the life of a JavaScript bug, this will enable you to do this. When you do this and prettify the JavaScript, you end up with 27,000 lines of code which are present within Adobe Reader as standard when you install the product. So, as I mentioned, Didier Stevens did some work on embedding dangerous files within PDFs, and one thing which we looked at is what mitigation Adobe had put in place. So essentially, we launched Reader, we embedded a file within a PDF and had a look in sysinternals to see what was going on. We identified this registry key here, which contains a blacklist of bad extensions. As with any blacklist, there might be gaps, and one of the things we looked at was whether there's any gaps that we could find. We had some success with some theme packs, for example, for Windows, but we didn't really get anything which was too valuable out of this, but I just thought it was worth sharing because it was something we did when we approached this piece of software. I'm going to hand over to James now, who's going to discuss how we approach the PDF rendering engine.
So, as Dave said, we started looking at Reader, mostly for Pwn to Own, and a lot of our efforts for that were looking at the JavaScript. But over the last couple of weeks, we decided we'd have a look at the rendering engine, because this is a huge attack surface. The PDF specification, for example, runs to 740-odd pages, and there's an Adobe supplement to that, which is another 140-odd pages. So there's a lot of features in the PDF file format, which means there's going to be a huge number of potential areas we can start looking at, particularly for fuzzing the PDF format. So what we wanted to do here is get as much code coverage from this as is possible. So we wanted to go out and get as many PDFs that could possibly cover all aspects of Reader before for when we fuzzed the PDF file format. There's kind of a couple of ways, I guess, we thought we could do this. We could either generate the PDFs ourselves. That might take a little while, but we've got the specification, we can probably go do that. The option we chose was just to go out onto the internet and just wget lots and lots of PDFs. I think we ended up with around 2 terabytes of PDFs after running wget recursively for about a week or so. Now that's great. We have lots and lots of PDFs, but we want to reduce the amount of PDFs we have before we fuzz them, because a lot of these PDFs aren't actually going to add new coverage. So we only want to fuzz PDFs that are going to add new coverage. So the way we did that is we wrote a little script around the Dynamo Rio drcov tool. What drcov does is it outputs the basic blocks that get covered when you execute an application, and this is quite useful. So we ran the PDF through Reader. drcov just injects a DLL, outputs the basic blocks, then we compare that to a database. If the PDF adds new coverage, great, we'll keep that, put that in our fuzzer. If it doesn't, well, we don't really care about it, we'll just drop that off. From that, I think we ended up with around 400 or 500 megs worth of PDFs from the original input size of 2 terabytes, which means we're going to be a little bit more likely of finding bugs because we're exercising lots of different code paths with the application. One thing before you start fuzzing PDFs that is worth mentioning, they're typically compressed, and it's worth uncompressing them first. You'll tend to get much better results if you're going to go out and fuzz these formats, which is obviously what we did. Again, lots of free tools online that did that. We just wrote a little wrapper script around one of the freely available ones. Reader is happy to accept compressed or uncompressed PDFs, so that's all good. Although, why bother fuzzing? Lots and lots of people spend a lot of effort fuzzing Reader. I know Project Zero have a load of bugs on their website where they've just gone out and fuzzed Reader. Adobe do it themselves. The idea is you need to fuzz a lot smarter. Just grabbing a couple of PDFs and throwing them through Reader, you're not going to get great results from it. But if you can exercise lots of different code paths, lots of different code coverage, you might have a better chance of getting bugs. And this is something that some of you probably know, American Fuzzy Lop, which is a really cool fuzzer, manages to do. It tries to exercise as much of the code as possible, and it has a really good feedback engine in there that allows it to do that. If you're on the AFL website, you'll see all the bugs it's found in some pretty high-profile bits of software. The other thing that's worth considering, which isn't actually what we did with Reader, but it's worth trying to distribute out your fuzzing runs as much as possible. So, as you'll see, we actually just used a couple of laptops, ran it for a week. If we could run that, cloud scale, get some AWS time over lots and lots of boxes, you're probably going to get some good success. So yeah, we got a few crashes from doing this. Like I said, all we did was a really simple bit flip, ran it for a week across a couple of laptops. I think we were launching a few Reader instances every few seconds, so nothing particularly quick, but we got a use after free, we got a null pointer deref, lots of boring rubbish crashes, but in total our fuzzer identified around 100 crashes, which we're still triaging. We only ran this, not last week, the week before I think it was. Currently, I'm just trying to write a proof of concept for the use after free. I'm going to report that to Adobe, obviously, but once we've done that, just very quickly, it appears to be an error in the way a font library is being handled. We're we're going to get that reported off to Adobe and write a little proof of concept. So hopefully keep an eye on our website. Probably publish something on there. The other thing, though, the problem with looking at the rendering engine is there are now quite a lot of mitigations in place. So if we'd got that use after free and managed to write a cool exploit for it or whatever, from Reader 9 and below, would probably have would have control of the user machine. From Reader 10, we've got this idea of a sandbox. So probably quite a lot of you know about this already, but the sandbox limits what our abilities of our exploit to call out to the operating system. Essentially, it goes through a broker process in Reader. Now, there's been quite a lot of work already done on the sandbox. These are a couple of papers which Dave mentioned at the beginning. Ultimately, it's not massively changed between Reader 10 and Reader 11. We have done a little bit of looking at the sandbox recently, and we're going to carry on looking at that as well. It's worth noting as well that the Reader sandbox is actually heavily based on the Chrome sandbox, but the differences are that with the Chrome sandbox, we have around 10 calls out to the OS, whereas in Reader there's 100 and something to support its rich feature set. Obviously, this gives us quite a nice attack surface for when you want to maybe look at the sandbox or try and fuzz it or something. So with that in mind, there's a few ways that you could consider trying to break out of the sandbox, which we'll go through in a minute. But with Adobe, the sandbox essentially looks like this. So when you launch Adobe, you actually launch two processes. So you get a really low privilege process, which is what renders your PDF, and then a second process, which is this broker process up here, excuse me, which essentially hooks all calls out to the OS to ensure that nothing weird and wonderful is going on. Again, the read-writes out to like the file system and registry keys, these are heavily restricted now. You can't just go and arbitrarily write to any bit of the file system. You can't just go right to a bit of the registry that you feel like. You'll get caught out there. So, as I mentioned, there are a few ways we can consider maybe trying to break out of this sandbox. A kernel ODE, probably quite difficult, but it's certainly a thing you could consider. And certainly that's, if you look at some of the Pwn to Own winners previously, that's some of the things that they have done. So, it's not to say that there aren't any bugs there. Logical flaws in the cross-calls? Yeah, okay. So Reader is continuously adding new features which need to be implemented in the sandbox. There's, certainly no reason to think that they wouldn't have made mistakes there. But one of the ways we're looking at is memory corruption in the cross-calls. So we're looking at building a sandbox fuzzer. This is kind of based on the work in the Breeding Sandworms paper, where they implemented something kind of similar, but they only implemented it on one call, I think. So we're looking at extending that a little bit and trying to fuzz a lot more of the calls out. Just very, very briefly, just the idea behind the sandbox fuzzing is you obviously have your PDF here, it goes to the Reader broker process. What we want to do is just hook that call and modify data. When a PDF is loaded, as we'll see a bit later, one of the actions you might want to do is try and access a website, for example. So you'd embed the URL in there. What we can do is, obviously that's a user controllable value, so we can hook that, modify that, insert fuzz data there, and try and watch out for some bugs. So that's something we're currently working on as well, along with all the other bugs we're looking at from the fuzzing. So that's actually all I wanted to talk about. So Dave is going to talk about some of the bugs we found in the JavaScript privileges system.
Thanks, James. So back to the JavaScript API, I just wanted to touch upon a mitigation which Adobe put in place to safeguard some of the more sensitive JavaScript functions which are inbuilt into Reader. So in Adobe Reader, there's a concept of privileged versus non-privileged context. This is defined in the Adobe documentation for the JavaScript API here. As you can see, some JavaScript methods marked with this little S icon, the little red icon, can only be accessed in a privileged context. So if you crafted a PDF and it's come, you've just downloaded it from the internet, you You can't, for example, use the launch URL method, which will launch a URL in a browser. So if you look at the paper I discussed about the life of a JavaScript bug, it describes this in more detail. But very simply, after we've done our enumeration, we've established what's there and what some of the inbuilt functions within Reader look like, and also we've compiled the bytecode, we can start to do essentially code review of some of these inbuilt functions. Some of the functions are marked as trusted. So here we define foo as a trusted function. This has a parameter bar. You begin the privileged operation, which increases the privilege of the stack frame. Some privileged stuff happens here, and then you end the privilege. One of the vulnerabilities which we've reported to Adobe, which we identified, basically involves bar being used in the privileged stuff. So you can call one of the trusted functions, which is present within Reader. You can manipulate the bar, which is an object which is passed in, and then in turn you get a privilege escalation with something. You control something which happens in the privilege stuff. So I just wanted to do a quick demo of our exploit of this. So first of all, I'm going to launch a PDF which tries to launch a URL in a low privilege context. As you can see, you get a security warning, which is preventing you from launching the URL, which is YouTube. You've got the option to remember this for future reference, but I'm not going to click that. I'm going to click cancel, just to prove that we're actually doing something here. Here's our exploit PDF. As you can see, there was no security dialog, and we get a nice song from Rick Astley. James, some of the you should have seen some of the PDFs which James was sending me with meat spin and all kinds of stuff. So finally, to summarize our talk, so what have we learned from our journey with Adobe Reader? Well, we've learned a methodology which can allow us to understand the attack surface of this product, how this can be reduced through hardening. Potentially, we've learned some things which can be implemented as security controls to mitigate the risks. So perhaps on boundary email and web filtering appliances, for an organization, you might flag or increase the risk associated with an attachment which has JavaScript or something like that in it. But the conclusion is that we've identified a number of bugs. We didn't know if we'd get anywhere with this project, but with a couple of laptops, we managed to get a use after free. With a bit of effort with the JavaScript API, we've managed to get a privilege escalation, and we've got plenty more to triage. So the long and short of it is, you should bother assessing popular software. So future work then, we're already starting to apply a similar sort of methodology for other products, and the tactics seem to be working. So we've already got bugs in Microsoft Visio, and we're working on other products. But we wanted to share this methodology so, this is something that you guys can do as well and pick products and start approaching them. Just because they're popular and they're used everywhere, they've maybe been looked at to death over the years, it's still worth a stab at them. So final thanks to Nils and Yong from MWR for their help, and of course the BSides crew for all their efforts in getting this event together, and also you guys for voting our talk to be at this event. So finally, just before I go on to the questions, actually, just a note that if you want to come to the MWR after party, come and see us at the stand. We'll be running the after party later on, and come and have a beer with us and have a chat about Adobe. But for the time being, is there any questions?